Welcome back to our Chem 151 video series. In this video, we'll learn how to use the ideal gas law to find a gas's molecular mass. Here, we're not given the identity of the gas, but we are given its mass. We're given 0.500 liters, we're given the pressure of 1,748 torr and 60 degrees Celsius, and we are asked to find the molecular mass. Let's remember that the molecular mass has a definition that is grams over moles. We are actually given the mass already, and that was the first piece of information we were given. We'll check that off because we already know the grams of the gas. So really, our goal is to get the moles of the gas and then plug it into this equation. Now, in order to get the moles of the gas, we'll need to use the ideal gas law. The ideal gas law says pressure times volume is equal to moles times R times T. Let's go through the rest of the information and find out which pieces we know. The next piece of information in the problem says 0.500 liters, and this is a volume which we'll represent with V. We'll write that down first. The next piece of information gives us a pressure of 1,748 torr. We'll represent that as P. However, pressure in this equation will not use torr, instead it will use atmospheres. So let's hit pause for a second and convert those torr over to atmospheres. We'll place atmospheres on top and torr on the bottom. 1 atmosphere is the same as 760 torr, so our operation is going to be to take 1,748 divided by 760. If we do the division, we'll get 2.3 atmospheres. This will be the pressure that we use in our ideal gas law. Next, we're also given that we have 60 degrees Celsius. This is a temperature, which we represent with T. However, degrees Celsius cannot be used in the ideal gas law. We must instead use Kelvin. To convert from Celsius to Kelvin, we'll add 273.15. If we add these together, we'll get 333.15 Kelvin. Therefore, so far, we have volume, pressure, and temperature. The R value for the ideal gas law for the purposes of Chem 151 will always be 0.0821 liter atmospheres per mole Kelvin. So we also know R. The only thing we don't know is moles, the N. We'll have to solve for N using some algebra. To solve for N, we're going to divide both sides by R and T to get N by itself. If we divide, our new equation will be N equals PV divided by RT. Since we know all 4 letters, we'll now place them in this equation. Pressure will be 2.3 atmospheres. Volume will be 0.500 liters. The R will be 0.0821. And the temperature will be 333.15. You can place all of this into a calculator. We will end up with 0.042 moles. Now that we have our moles, we can find our molecular mass. Now the mass that we were given at the beginning of the problem was 1.10 grams. That will go into the top position, and the N that we found with the ideal gas law will go to the bottom position. Therefore, our molecular mass will be 1.10 divided by 0.042. If we do the division, we will get 26.16 grams per mole. And so this is how we can use the ideal gas law to find molecular mass. Thank you for watching, and we'll see you again soon.